All right, hello. This is video 2 of several for the statistics module on sampling frequency distributions and graphs. The two things we're going to do in this video are look at deceptions and visual displays of data and how correlations are often misunderstood. So firstly, we'll take a look at these charts. In the middle, you have the data from year 2001 to 2005 on the poverty rates, 11.7% all the way up to 12.6%. And on the left and right, you'll see graphs that show the rate of poverty increasing very differently. So see if you can pause the video and figure out how the graph on the left and the graph on the right are skewing the information. And then let's resume the video. The graph on the left stretches the scale on the vertical axis to create an impression of a rapidly increasing poverty rate. Notice here the scale is going by 0.4%, whereas the graph on the right compresses the scale on the vertical axis to create an impression of a slowly increasing poverty rate. Here, our vertical scale is going by 4%. So we see a very different picture depending on which graph we look at. Here are some things to watch out for in visual displays of data. 1, is there a title that explains what's being displayed? 2, are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression than shown by the actual data? 3, do too many design and cosmetic effects draw attention from or distort from the data? 4, has the wrong impression been created about how the data are changing because equally spaced time intervals aren't used on the horizontal axis? Furthermore, has a time interval been chosen that allows the data to be interpreted in various ways? 5, are bar sizes scaled proportionally in terms of the data they represent? And 6, is there a source that indicates where the data in the display came from? Does the data come from an entire population or a sample? Was a random sample used? And if so, are there possible differences between what's displayed in the graph and what's occurring in the entire population? Who's presenting the visual display, and do they have a special case to make for or against the trend shown by the graph? So here's an example. I'd like you to try and pause the video and see if you can figure out why this visual display is misleading. Okay, here you have the number of square feet in an average US single family home, the years on the horizontal axis, and the square feet here, sort of on a vertical axis. All right, pause the video and let's resume. Well, firstly, you notice that the cosmetic effects of home with equal heights, so the homes have equal heights, but they have different frontal additions, and they shadow lengths, which make it impossible to tell if they're proportionally depicting the given areas. Next, notice that the time intervals on the horizontal axis aren't uniform in size, which makes it appear that the dwelling swelling has been linear from 1980 through 2010. So you see from 1980 to 1990 is 10 years, and then from there to 2010 is 20. So that's uneven here. Let's actually do the math to see what's happening. So if we take the difference in the square footage from these two, 1980 and 1990, we get 340. Divide that by the 10-year time span, and we get 34 square feet on average per year. Let's do the same for 1990 to 2010. Subtracting those square footages, we get 312, and dividing that by the 20 years that time has elapsed, we get 15.6 square feet on average per year. This is quite a big difference, more than double over the first 10 years here. And so the data indicate that it's not the case, what we were actually seeing. There's actually a greater increase in area from 1980 to 1990 than from 90 to 2010. And so we actually are being kind of fooled right here with these shadows. All right, next up is correlations. A correlation, as you might expect, co and relation being together, is a mutual relationship between two things. It's an interdependence of variable quantities. Watch out, correlation does not imply causation. So an example here, we have a scatter plot of sleep versus test performance. So the more sleep these seniors in high school got, the greater their test score. And the source is here on the bottom. We can look some more at that. And watch out for the spurious correlations. So just because two things seem to be correlated doesn't mean there's a causation, right? And so here's a perfect way to show that example. And there's a great website on tylerbagan.com that has lots of these spurious correlations. So for example, the divorce rate in Maine happens to correlate with the per capita consumption of margarine. The same for the per capita consumption of chicken, which correlates with the total US crude oil imports. All right. That's the end. Thanks for watching.